this video, I am going to explain about S-block elements. So, very important topic. So, first we will discuss important synopsis. So, first alkali metals. S-block contains two groups. First alkali metals. Next general characteristics of compounds of alkali metals. That means some important compounds of sodium. Next alkaline earth metals. Important compounds of calcium and biological importance of calcium and magnesium. We will discuss one by one. First here, what are S-block elements? The elements in which differentiating electron enters into S subshell or S orbital or S-block elements. So S-block contains two groups of elements, 1A and 2A. So 1A group is alkali metals, and 2A group alkaline earth metals. S-block contains two groups, first A and second A, or in IUPAC system, first and second groups. Next. So general electronic configuration is NS122, or we can write general electronic configuration NS122. So for alkali metals NS1, alkaline earth metals NS2. Therefore NS122, where N is valence shell. N is valence shell. Remember these 2 points. Next. So about alkali metals, first A group elements. So lithium, sodium, potassium, rubidium, cesium and francium are 1A group elements. So oxides of first A group elements form hydroxides when they react with water, which are strongly alkaline. Therefore, these are known as alkali metals. We'll give an example. First A group elements form hydroxides when they react with, suppose, Na plus H2O. So 2Na plus 2H2O, 2NaOH plus H2. So this is alkaline in nature. So therefore first A group elements are known as alkali metals. Alkaline means basic. Basic nature. Next point. General electronic configuration of 1A is NS1. Only one valence electron is present. Next, these are highly electropositive because they can lose electrons, S electrons, very easily. These are most electropositive. First A group is most electropositive elements. Very important. These elements can lose S electrons very easily. Next. These are readily lose one electron to give M plus ions. That means simply Na gives Na plus with release of one electron. So Na plus will be having neon configuration, noble gas configuration, which is highly stable. So here neon and 3s1. Neon configuration highly stable. Therefore, they can lose one electron easily. So therefore, the most common oxidation state is oxidation state of first A is +1 due to loss of one electron. Next. In periodic table, The largest size is for 1A group. If you take any period, in their respective periods, alkali metals are having largest atomic radius. Next, alkali metals are having low ionization potential due to large size. Due to large size in their respective periods. Next, so down the group, ionization potential decreases due to increase of atomic radius. Due to increase of atomic radius and decrease of nuclear charge. So down the group, ionization decreases. So ionization leads to for cesium and francium. Therefore, they can lose electrons more easily. Next, in alkali metals, outermost electron is very well screened from nuclear charge. So screening effect of inner electrons will be more. Therefore, it is very easy to remove last electron. So down the group, hydration enthalpies decrease. That means if you take lithium, sodium, potassium, rubidium, cesium, francium radioactive, leave that. Na plus, K plus, Rb plus, Cl plus, and first Li plus. So in this direction, hydration energy increases. Cs plus to Li plus, hydration energy increases. Therefore, down the group, hydration energy decreases. Next. So order of hydration energy is given. Lithium highest, cesium least. Next, order of melting and boiling points. Melting and boiling points, here order should be like this. Order of melting points, here it should be like this. Order is reversed here. It should be like this. Li, Na, K, Rb and Cs. Lithium has highest melting and boiling point. So due to more metallic bond strength. Remember that point. Next. So melting and boiling points of alkali metals are low when compared to D block elements due to weak metallic bonding. Their metallic bond strength, lithium to cesium, decreases. Next, when compared to S block and D block, so melting and boiling points are more for D block due to more metallic bond. Next, lithium has maximum degree of hydration due to small size. Therefore, it is hydrated. It can form hydrated salt, LiCl dot 2H2O. Next, all alkali metals are silvery white, soft and light metals. So these are lighter metals when compared to D block. Next, these are having low density due to large size. In respective periods, alkali metals are having large atomic radius. Order of density, density increases. Lithium to cesium, mass increases. But here exception is sodium to potassium. So density of sodium is more than that of potassium due to abnormal increase of size. Due to abnormal increase in size of potassium. Potassium will be having lower density when compared to sodium. Next, abnormal density of potassium is due to abnormal increase in atomic size. Next, alkali metals and their salt show flame colors. Lithium crimson red, sodium golden yellow, potassium violet or lilac, rubidium reddish violet, cesium bluish violet. These are flame colors. Remember that point. Flame colors and density. These 3 points are very, very important. Next. Calcium and potassium are generally used in photoelectric cells due to low ionization energy. Next, reactivity. Here calcium will write cesium. Here we are discussing about 1A group. Therefore, CaE, cesium and potassium are most commonly used in photoelectric cells. Next. So due to low ionization energy values, reactivity of these metals increase down the group due to high reactivity. Therefore, 1A group metals are not found in free state. Next, lithium forms only monoxide. Now let here, lithium forms only monooxide. Sodium forms peroxide. Potassium, rubidium, cesium can form superoxides. That means reactivity in this direction increases. Reactivity towards oxygen. Reactivity order. Lithium to cesium, reactivity towards oxygen increases. Next. See, this point is given. Lithium forms only monoxide, sodium forms monoxide and peroxide also, peroxide. Remaining can form superoxides. So, oxide formula O2 minus, here O2 2 minus, here O2 minus. Remember formula also. Next. So, only lithium directly combines with nitrogen to form lithium nitride. So, among alkali metals, only lithium can form lithium nitride. Next. Common oxidation state is +1. Already we have discussed this point. Next. So due to high reactivity towards air and water, alkali metals are kept under kerosene. Kerosene is non-polar compound. Next, alkali metals react with water to form hydroxides and hydrogen gas is released. Next, lithium reacts with water less vigorously than sodium, even it has high negative E0 value. High negative E0 value when compared to remaining. So due to its small size. Next, except lithium, other metals of first A react explosively with water. That means reactivity from lithium to cesium increases down the group. So alkali metals react with proton donors such as alcohols, NH3 and alkynes. So alcohols means I will write one example. Alkali metal can react with proton donors such as alcohol. I am taking C2H5OH. So this will form C2H5O minus Na plus half H2. So here ethyl alcohol is donating proton H plus. That means sodium displaces hydrogen. Next, all the alkali metals hydrates are ionic with high melting points due to high lattice energy. Next, lithium halides are covalent due to Small size of Li plus. Small size. It has maximum polarizing power. Polarizing power. As the size of cation, as the cation, size of cation decreases, polarizing power increases according to Fajan's rules. Fajan's rules. Remember this point. Next. Alkali metals dissolve liquid ammonia to give deep blue solution. Deep blue solution. So color is due to ammoniated electrons. These are ammoniated electrons and the solution is paramagnetic in nature due to unpaired electrons. Next, uses of alkali metals. Lithium is used in making alloys. That is white metal. White metal is lithium and lead alloy. It is used in bearings. So in motors, bearings will be there. In that bearings, it will be used, white metal. Next, it is used to make electrochemical cells. Electrochemical cells means nothing but batteries. Next, sodium is used to make sodium lead alloy, which is used to prepare tetraethyl lead, anti-knocking agent, tetraethyl lead. Next, liquid sodium metal is used as coolant in nuclear reactants. Sodium metal is used as coolant for cooling purposes in nuclear reactions. In nuclear reactions, more amount of energy will be released. Temperature will be very high. Therefore, liquid sodium is used. Next, potassium is used in fertilizers, manufacture of soft soaps, and it is good absorber of CO2. So, for absorbing CO2, potassium compounds can be used, KOH simply. Next, so compounds of alkali metals, oxides and hydroxides. Oxides and peroxides are colorless, but superoxides are yellow or orange due to the presence of unpaired electrons. So color is due to unpaired electrons. Next, first A group elements react with water to form corresponding hydroxides. We know that with release of H2 gas. Next, halides. All halides having negative enthalpies of formation. Negative enthalpies of formation means exothermic products. All are stable. So melting points, boiling points are fluorides, chlorides, bromides, iodides due to lattice energy. This lattice energy order. Next. So these are soluble in water due to ionic nature. Next, lithium is soluble in pyridine also. Pyridine is non-polar solvent. So due to covalent nature, LiCl is soluble in organic solvents also. Next, salts of oxo acids. Carbonates, bicarbonates are stable towards heat. Carbonates, Na2CO3 and K2CO3 are stable towards heat. That means thermally stable. And stability increases down the group. It is down the group, stability of carbonates and bicarbonates increases. So most commonly used carbonates are sodium carbonate and potassium carbonate. There is no effect of heat on Na2CO3, K2CO3. Thermally stable. Next, lithium bicarbonate does not exist as solid. It is available in liquid state. Highly soluble. LiHCO3 available in liquid state, does not exist as solid. Remaining are solids. Next, anomalous behavior of lithium due to small size, high polarizing power. Anomalous properties are due to small size, high polarizing power and due to absence of d orbitals in valence shell. Small size, high polarizing power. It is hot, least reactive and forms hydrated salts. These are anomalous properties. Anomalous properties means properties of lithium different from that of rest of the elements. Next, LiHCO3 is not obtained in solid state. It is available in liquid state. Remaining are solids. Next, lithium forms ethanide on reaction with ethane. No reaction. Remaining elements can form ethanide, but lithium cannot form ethanide due to its small size. I will explain this topic in organic. Next, lithium nitrate, when heated, it forms lithium oxide, whereas remaining can form nitrides. That means LiNO3 on heating gives Li2O NO2 plus O2. Remaining NaNO3 on heating gives NaNO2 plus O2. Nitride plus O2. Important property. Next, lithium compounds are less soluble in water due to covalent nature. Next, diagonal properties between lithium and magnesium. So, due to small size, lithium and magnesium show similar properties. So, both are harder and lighter than other elements. Next, lithium and magnesium react slowly with water. Remaining elements can react fastly. Next, both can form nitrides when they combine with nitrogen. Next, carbonates of lithium and magnesium decompose on heating to form oxides and CO2. Next, LiCl, MgCl2 are soluble in ethanol due to covalent nature. Next, both form hydrated salts, 2H2O, 6H2, hydrated salts. Next, important compounds of sodium. First, sodium hydroxide. It is also known as caustic soda. So, it is prepared by Kastner-Kellner process. Kastner-Kellner process or mercury cathode method. Mercury cathode method. So, very, very important. Next, anode is carbon, cathode is mercury. Next, here electrolyte is brine solution, that is concentrated solution of NaCl, brine solution. Next, at cathode, amalgam will be released. Amalgam. Next, at anode, Cl2 gas is released. Next, from amalgam, we can get NaOH. So, amalgam acts, here three compartments will be there, three compartments, outer compartments and middle compartment. In outer compartment, sodium amalgam is formed. That will be shifted to middle compartment. In middle compartment, NaHe acts as anode. From that, we will get NaOH. Next, uses of NaOH. So, manufacture of soaps, paper, artificial silks and different substances, chemicals. Petroleum refining, purification. And purification of bauxite by Bayer's process. In Bayer's process, NaOH can be used. Next, in textile industries for mercerizing of cotton. Mercerizing means here strengthening of cotton threads. Strengthening. It acts as laboratory reagent. So many purposes. For so many purposes, NaOH can be used. Next, sodium bicarbonate and sodium carbonate. So sodium bicarbonate is baking soda. Baking soda. It is used in preparation of baking powder. So Na2CO3, sodium carbonate plus H2O plus CO2 gives sodium bicarbonate. So it is mild antiseptic for skin infections. Next, used in fire extinguishers. Soda acid fire extinguishers contain sodium bicarbonate. Next, sodium carbonate. Commonly, it is known as washing soda, Na2CO3.NH2O. It can be prepared by solvase process. Solvase process steps. First, ammonia solution. When CO2 is passed through ammonia solution, we will get ammonium carbonate. If excess of CO2 is passed through ammonium carbonate solution, we will get bicarbonate. So, this bicarbonate, when treated with NaCl common salt, it gives sodium bicarbonate. Sodium bicarbonate on heating gives sodium carbonate. Next here, one more point, recovery of ammonia. It can be done by taking NH4Cl. This NH4Cl reacts with slake lime or alkalis to form, take 2 moles of NH4OH plus CaCl2. So this is nothing but 2 moles of NH3 plus 2 moles of H2. So from this reaction we can recover ammonia. It can be used again. Next, properties of sodium carbonate. This is very important. On heating, decahydrate loses water molecules to form monohydrate. See, a decahydrate means 10 water molecules. When heated 373 Kelvin, below 373, it loses 9 water molecules. 1 water molecule is left, monohydrate. If temperature is above 373, it gives Na2CO3, which is known as soda ash. Soda ash. Effect of heating. Next, uses, water softening, cleaning, and in laundries it can be used. Paper, paints, textile industries, manufacture of glass, soap, borax, and NaOH. Next, important laboratory reagent. Next, biological importance of sodium and potassium. So, transmission of nerve signals. Next, regulates flow of water. Next, transport of sugar and amino acids into cells. Next, activating enzymes. Enzyme activators. Next, oxidation of glucose to produce ATP. Adenosine triphosphate. These are biological importance. Next, alkaline earth metals, 2A group elements. So, magnesium, calcium, strontium, barium, radium are alkaline earth metals except Be. So, why Be means Be can form amphoteric. Be can form amphoteric oxide and hydroxide. Remaining elements can form basic oxides and basic hydroxides. Therefore, remaining elements are alkaline earth metals except beryllium. Beryllium can form amphoteric oxide and amphoteric hydroxide. BeO and BeOH twice. These two are amphoteric. Remaining oxides and hydroxides are basic alkaline. Therefore, remaining elements are alkaline earth metals. See here, these elements react with water to produce oxides and hydroxides which are basic in nature. But oxide and hydroxide of beryllium are amphoteric. Therefore, except beryllium, remaining are alkaline earth metals. Next, fifth most abundant element in earth crust is calcium. Sixth most abundant is magnesium. Remember this point. Order of abundance. That means calcium, magnesium are more abundant elements in 2A, alkaline earth metals. Next, general configuration NS2, Next, all alkaline earth metal compounds are ionic except beryllium. Beryllium can form covalent compounds due to small size. Beryllium compounds are covalent. Very, very important. Next, in group, atomic and ionic radius increases with increase in atomic number. Down the group, atomic radius, ionic radius increases. Next, alkaline earth metals have high ionization energies when compared to alkali metals due to small size. From first A to second A, size decreases. Next, order of hydration. Be2 plus highest, Ba2 plus least. Next, hydration enthalpies of alkaline earth metals are almost double to that of alkali metals. That means when compared to hydration energy of Li plus, Be2 plus hydration energy will be almost double due to small size. Next, alkaline earth metals are more hydrated than alkali metals due to small size. So MgCl2 6H2O, CaCl2 2H2O or 6H2O. 6H2O also possible. CaCl2 6H2O. In case of alkali metals, only 2H2O is present for lithium, but here 6H2O, more hydration. Next, beryllium and magnesium colors gray color. Next, alkaline earth metals are hard, therefore they are having high melting and boiling points when compared to alkali metals. Next, alkaline earth metals are electropositive due to low ionization. But when compared to alkali metals, alkaline earth metals are less electropositive. So first A group elements are most electropositive. 2A group elements are less electropositive when compared to first A. Next, in a group from top to bottom, reactivity increases from beryllium to barium. Next, beryllium magnesium do not react with oxygen and water due to formation of protective layer on the surface of beryllium magnesium, protective coating. Next, powdered beryllium burns with air to give BeO and Be3N2, both oxide and nitride. Next, powdered magnesium burns with dazzling brilliance, brilliant white light to form oxide and nitride. Next, calcium strontium barium directly react with air to form oxides and nitrides. That means reactivity towards oxygen increases down the group. That means all 2A elements, can form oxide and nitride when exposed to air. All elements can form. But in case of alkali metals, only lithium can form nitride. Next. So BF2 can be prepared by thermal decomposition of ammonium fluoroberylate. This is a very, very important point. Next. Alkaline earth metals react with acids liberate H2 gas, similar to that of alkali metals. Next, Strong reducing agents due to large E0 values, SRP values, standard reduction potentials. Next, beryllium has less negative E0 value. Next, alkaline earth metals dissolved in liquid ammonia to give deep blue black solution. In case of alkaline metals, blue solution. Here, blue black solution due to ammoniated electrons. Color is due to ammoniated electrons. Next, uses. Copper beryllium used in preparation of high strength springs. Next, metallic beryllium used in making windows of X-ray tubes. Magnesium aluminum, aircraft construction, aircraft part construction. Next, suspension of magnesium hydroxide is known as milk of magnesia. Suspension of MgOH twice in water is milk of magnesia. It is used as antacid. Next, toothpaste contains MgCO3. Extraction of metals from their oxides, calcium can be used. Calcium is powerful reducing agent, therefore it can be used. Next, calcium, barium are used to remove air from vacuum tubes. They can react with oxygen, that removes oxygen. Next, treatment of cancer and radiotherapy, radium can be used, radioactive. Next, so alkaline earth metals are ionic due to increase in nuclear charge and smaller size. They can lose electrons more easily, therefore they can form ionic compounds. Next, beryllium oxide, beryllium hydroxide are amphoteric. Remaining oxides and hydroxides are alkaline or basic. Next, solubility, thermal stability, basic nature of alkaline earth metal hydroxides increases down the group. Very, very important. Next, BaCl2 is polymeric in solid state. In solid state, BaCl2 should be there here. BaCl2 is polymeric in solid state. Next, so below 1200, it will be dimer. We have let here in solid state. In solid state, BaCl2 polymer. Next, so below 1200 kelvins, BaCl2 dimer, and above 1200 kelvins, BaCl2 monomer. Remember this point. Structure of BaCl2. Here in vapor state, it dissociates into monomer. Above 1200 monomer, single unit. So below 1200 dimer, 2 units will be joined. In solid state, perfect polymer. Next. See, hydration decreases down the group. So here Ba. It should be BaCl2. See here magnesium and calcium can form octahydrates, 8H2. So magnesium 8, calcium 8 or 6, strontium also 6, but barium 2. Hydration decreases down the group. Barium, due to large size, it can form only dihydrate. Next, solubility of carbonates decreases down the group. This is solubility of carbonates and sulfates due to decrease of hydration energy. So Be to Ba. In case of carbonates and sulfates, solubility decreases due to decrease of hydration energy. Be2 plus has more hydration energy, more soluble. Next. So all alkaline earth metal nitrates decompose on heating to give respect to oxides. Oxides NO2 and O2. Suppose I will write an example. MgNO3 twice magnesium nitrate on strong heating gives MgO plus NO2 plus O2. Oxide NO2 and O2. Next, beryllium shows diagonal relationship with aluminium. Next, beryllium forms covalent compounds due to small size and high ionization energy. Next, so beryllium coordination number is 4, but for remaining elements coordination number is 6. That means beryllium maximum covalency is 4. Remaining elements can expand their valency up to 6 due to the availability of d orbitals in valence shell. So Be can form maximum valency 4, berylate ion. Next, while aluminium can expand its valency up to 6, hexavalent, due to availability of d orbitals. Next, so one more important point. So beryllium and magnesium do not impart color to flame due to high ionization energy. Very important, and previous question. So for remaining elements, flame colors will be there. Beryllium and magnesium do not impart any color to flame due to very high ionization energy. Next, important compounds of calcium. So limestone on heating gives quicklime. CaCO3 1270 kelvins, approximately 1273 can take, gives CaO plus CO2. This is quicklime, CaO. Next, when quicklime exposed to atmosphere, it absorbs moisture to form CaOH twice. That means this reacts with water to form CaOH twice, which is slake lime. Next, see here, limited amount of water is added to quicklime. It breaks lumps of lime. This is called slaking of lime. So CaO reacts with water to form CaOH twice. This process will be slaking of lime. Next, NaOH and CaO mixed is soda lime. Next, aqueous solution of CaOH twice is lime water. It is used for whitewashing or detection of CO2. Next, suspension of, that means thick solution of CaOH twice is milk of lime. Aqueous solution is lime water, but a thick solution is milk of lime. Next, CO2 gas passed through lime water, it turns milky due to formation of CaCO3. So lime water, CO2 is passed. It gives CaCO3 by PPT plus H2O. So if excess of CO2 is passed through this solution, it gives CaHCO3 twice, calcium bicarbonate. It is completely soluble. That means milkiness disappears. Milkiness is due to formation of CaCO3. So by the addition of excess amount of CO2 to this solution, milkiness disappears due to formation of calcium bicarbonate. This point is given here. In the excess of CO2, carbonate will be converted to bicarbonate, then milkiness disappears. Next, when milk of lime reacts with chlorine to form bleaching powder CaOCl2. Next, so slake lime CaOH2C is used in whitewashing, using glass making, tanning industry, that means leather industry, preparation of bleaching powder and purification of sugar also. Next, calcium carbonate reacts with acids to form CO2 gas. We know CaCO3 plus we take HCl, take 2 moles, CaCl2 plus H2O plus CO2. Almost neutralization reaction. Next, CaCO3 is used in building material along with MgCO3, and it is used as flux in extraction of iron. In blast furnace it can be used. Next, hemihydrate of calcium sulfate is plaster of Paris. Hemi means half. Next, plaster of Paris is obtained from gypsum at 293 kelvins. That means at 100 degrees centigrade. Next, anhydrous CaSO4 is dead burn plaster. So sticky nature will disappear. Next, composition of Portland cement. See, remember here major composition and minor composition. Major composition CaO. After that SiO2. Minimum composition iron oxide and sulfur trioxide. Portland cement. Next. See here, for good quality cement, ratio of silica to alumina lies between 2.5 and 4 percentage ratio. Next, for good quality cement, the ratio of lime to the total oxides of silicon, total oxides will be closer to 2. Next, in the manufacture of cement, 2 to 3% of gypsum is added to slow down the setting process. The purpose of addition of gypsum to slow down the setting process. Next, biological importance of calcium and magnesium. Biologically. So here all enzymes utilize ATP in phosphate transfer require magnesium as cofactor. Cofactor means nothing but a catalyst type. That means chlorophyll contains magnesium. Chlorophyll, green part of leaves. Human body contains 99% of calcium, which is present in bones and teeth. Next. Calcium play important role in neuromuscular function. Neutral transmission, cell membrane, blood coagulation. Next, calcium maintained by two hormones, calcitonin, parathyroid. So this is the end of synopsis. Next we will discuss questions. So next we will discuss about worksheet questions. So first, unknown inorganic compound A is used for water softening, reacts with Na2CO3 to form an alkaline compound B whose pH is 14, that means strong base. A on reaction with CO2 gives cloudy PPT B, cloudy PPT. Next, B plus CaO reacts with unknown organic compound to form C. A, B, C respectively are. Let here. So first, compound A is water softening CaOH twice. In Clark process, it can be used. That reacts with Na2CO3 to form CaCO3 plus 2 moles of NaOH. Here compound A is CaOH twice. Next, this is having strong base, pH is 14. So this will be compound B. Next, A on reaction with CO2. CaOH twice reacts with CO2 to form cloudy PPT. That means CaCO3 white PPT plus H2O. Very, very important. Next, B plus CaO reacts with unknown organic compound C to give C6H6. Unknown organic compound can be COOH. Unknown organic compound, this would be C, that reacts with NaOH and CaO. And NaOH is B, B plus CaO. So decarboxylation reaction, decarboxylation. So here CO2 will be removed, minus CO2. It gives benzene, which is C6H6. So decarboxylation reaction, very, very important. So therefore, A is calcium hydroxide, B is NaOH, and C is benzoic acid. So option C. Next. So which are the following salts can accommodate more number of H2O molecules as per halide hydrates? So MgCl2 can accommodate maximum of 8 water molecules, that is octahydrate due to high hydration energy. Very, very important. So down the group, hydration capacity or tendency decreases. Therefore option B. CaCl2 can form 6H2O, hexahydrate. Strontium also 6H2O, but barium just 2H2O. Hydration ability down the group decreases due to decrease of hydration energy. Option B. Next. So lithium nitrate on heating gives lithium nitrate LiNO3 on strong heating, lithium oxide NO2 and O2. So NO2 reddish brown gas, and O2 we know colorless gas. Remember this reaction, very, very important. Option B. Lithium oxide, nitrogen dioxide and O2. Next. So lithium chloride, magnesium chloride are soluble in ethanol. Lithium and magnesium are harder than their respective group elements. The correct option among the following. Say lithium chloride and magnesium chloride soluble in ethanol. So these are covalent, therefore soluble. LiCl and MgCl2 soluble in C2H5OH. So this is non-polar solvent. These two are covalent. therefore soluble in non-polar solvent, which is correct. Next, lithium, magnesium are harder than the respective group elements. So, due to more metallic bond strength, that is also correct. So, therefore, option will be both are correct, but reason is not correct explanation. Therefore, option B. There is no relation between assertion and reason. Lithium and magnesium are hard when compared to other elements. Other elements of respective groups. So both are correct. Option B. Next, the balanced equation A by B is, so CaCO3 plus H3PO4 gives Ca3PO4 twice. Ca3 should be there. Ca3PO4 twice plus CO2 plus H2. So here make it 2, here 3. So 3 moles of H2CO3, that means here 3 and here 3. This is the equation, balanced equation. So here A is 3, B2, C1, D3, not D, here P is given, P is 1, Q is 3 and R is 3. Therefore, A by B, which is 3 by 2. Option B. Simple, just balancing only. What is the increasing order of hydration enthalpies of alkali metal ions? Hydration enthalpies. Lithium, sodium, potassium, rubidium, cesium. Hydration means aqueous. Aqueous hydration energy highest for Li plus due to small size. Hydration. Hydration energy is highest for lithium. So increasing order means we can write like this: Cs plus, Rb plus, K plus, Na plus, and Li plus. This is increasing order. So first one decreasing order, next increasing order. Both are correct. Here also you can write aqueous. Aqueous hydration energy cesium plus to Li plus increases. So option C. Next. So which are the following reactions represent slaking of lime? So now only we have discussed CaO reacts with H2O to form CaOH twice. So this will be quicklime and this is slaked lime. So option C. Next. So which are the following products are formed on hydrolysis of NaO2? So NaO2 we know superoxide reacts with H2O to form, see here, NaOH, which is strong base, plus H2O2 plus O2. So after balancing, we'll get 2NaOH plus O2. Here 2H2. So sodium superoxide. Any superoxide on hydrolysis gives corresponding hydroxide H2O2 and O2. So A, B, C. That means option D. Next. The set represents right order of ionic radius. So here Li plus Na plus first A group, Ba2 plus, here Li plus should be there, Li plus. Next in D option, here it should be Ba2 plus. 1 second. Greater than Ba2 plus should be there. Ba2 plus Mg2 plus 2A group elements. So when compared to 2A group elements, first A group elements are having more size. Therefore, we can arrange Na plus greater than Li plus greater than Mg2 plus greater than Ba2 plus. This is size order, decreasing order. So it is present in Na plus, Li plus, Mg2 plus, Ba2 plus, option D. So 1A group will be having more size when compared to 2A. Size order. Based on this, option D. Next. So white metal is alloy of lithium and lead. Lithium and lead. Use white metal bearings are used in motor engines. Very, very important. So option D. Lithium and lead. Used in preparation of bearings, which are used in motor engines. Next. The nitrate, which does not give nitrogen dioxide on strong heating. Suppose NaNO3 on heating, take 2 moles. NaNO2 plus O2 is sodium nitrate on heating gives nitrite. It will not give nitrogen dioxide. Therefore, option B. Next. So, which of the following reaction is not an example of hydrolysis reaction? Here, option D. Why? Because fluorine has no d orbitals in valence shell. Therefore, no hydrolysis. So, for hydrolysis, the element must accept water molecules. So, here there is no vacancy in fluorine. Therefore, it cannot accept. Therefore, that is not hydrolysis. Next. The compound that is used in smoke screens. So, very, very important. smoke screens. Ca3P2 on hydrolysis gives CaOH twice 3 moles plus 2 moles of pH3 phosphine gas. Phosphine gas, which on reaction with O2 to form P2O5, which is white dense fumes or white dense smoke. It acts as screen. Very, very important. Calcium phosphide. Very, very important. Calcium phosphide and hydrolysis will give phosphine gas, which on reaction with O2 produces white dense smoke of P2O5, phosphorus pentoxide, that acts as smoke screen. Therefore, option D, calcium phosphide. Next, the pair of elements which can form both oxides and nitrates when burnt with air. That means all second A group elements can form oxide and nitride on reaction with O2. Here magnesium, calcium are present. Mg plus O2 gives MgO, 2 moles, 2 MgO. Mg plus N2 gives Mg3N2 nitride, 3 Mg. Similar to that of magnesium, calcium also can form Ca plus O2 gives 2 CaO, 3 Ca plus N2 gives Ca3N2. Oxide nitride, oxide nitride. Therefore, option C. Next. So, MgSO4 is readily soluble in water. The greater hydration enthalpy of Mg2 plus overcomes its lattice energy. So, we'll write here beryllium, magnesium, calcium, strontium, barium, sulfates. So, in this direction, solubility increases. BSO4 is highly soluble due to high hydration energy of Be2 plus. So, in this direction, check here, hydration energy increases. In this direction, lattice energy increases. Remember like this, easy to understand. Barium to beryllium, hydration energy increases, therefore solubility increases. Beryllium to barium, lattice energy increases, therefore BaSO4 is PPT, highly insoluble. Therefore option A, correct explanation. Next. So alkali metals are powerful reducing agents due to their low ionization energy. First A group are alkali metals reducing due to low ionization energy. So reducing means here loss of electrons. So due to low ionization energy, they can lose electrons more easily. Therefore, they are powerful reducing agents due to low ionization energy. Next. Two metals A and B having similar atomic size react with oxygen to give only monoxide and nitrogen to give nitride. A, B are. Here lithium and magnesium can show diagonal relationship. So therefore, lithium with oxygen forms Li2O Lithium with N2 forms Li3N. Similar, magnesium with O2 forms MgO. Magnesium with N2 forms Mg3N2. Both are forming oxides and nitrides. Therefore, option C. Diagonal relationship. Next. KO2 reacts with water to form three compounds A, B and C. Here A should be there. A, B and C. B forms C when it reacts with iodine in basic medium. What are B and C respectively? So very important. Check here. KO2, potassium superoxide, when reacts with water 2H2O will form 2 moles of KOH, strongly alkaline, H2O2 and O2. Here A, B and C. Next. So what is B? B H2O2. B forms C when reacts with iodine in basic solution 2KOH. It gives 2 moles of Ki plus 2H2O plus O2. This is C. So therefore option, so we should find B and C on B H2O2, C is O2 and D option. Next. Which of the following are correct? NaH reacts violently with water to form NaOH and H2. NaH plus H2O, Na plus H minus, and here H plus OH minus gives NaOH plus H2 gas. This is correct. Next, an example for electron rich hydrates. Electron rich hydrates will be formed by 15, 16 and 17 group elements. So ammonia is 15th group element. That means N is 15th group element, NH3 due to lone pairs. It is electron rich hydrate. Therefore both are correct, 1 and 2. Next, what about 3? Nickel forms selene hydrate. Nickel is D block element. Selene hydrates are formed by, selene means ionic, formed by S block elements. But here nickel is D block. Therefore 3 is incorrect. 1 and 2, D option. Next. So here Na plus, here plus should be there, Na plus. And Mg2 plus ions are isoelectronic, but ionic radius of Na plus greater than that of Mg2 plus. So we know in case of isoelectronic species, Na plus, Mg2 plus. So atomic number here 11 and here 12. So atomic number increases in this order, but size will be in this order. So this is size order. Na plus more. So effective nuclear charge of Na plus ion is less than that of Mg2 plus ion. So due to, so here Z effective will be more for Mg2 plus. Mg2 plus Z effective greater than that of Na plus Z effective. Therefore size will be less for Mg2 plus and more for Na plus. Therefore option B. Both are correct and correct explanation. Next. Alkali metals are soft and having low melting and boiling points. So interatomic bonds are weak. That means alkali metals 1A soft due to less metallic bond strength. So therefore correct explanation. So option D. So alkali metals are soft when compared to D block due to less metallic bond strength. Interatomic bonds means metallic bonds. Next. So oxide of potassium that does not exist. So for potassium we can write K2O oxide, K2O2 peroxide and KO2 superoxide. These are possible oxides for potassium. So K2O3 not possible, does not exist for potassium. Next, dead burnt plaster is. So first take gypsum CaSO4.2H2O, gypsum on heating to 100 or 120 degrees. It gives CaSO4 dot of H2O, plaster of Paris. So which on strong heating above 200, it gives CaSO4. This is dead burnt plaster. That means it will not be having sticky nature. Therefore, option A, CaSO4 is dead burnt plaster. So this one gypsum and this one plaster of Paris, POP. Therefore, option A. Next question. The salt which responds to dilute and concentrated H2SO4. Here barium nitrate, BnO3 twice plus H2SO4 dilute will form BaSO4 plus 2H plus 2NO3 minus. But same barium nitrate reacts with H2SO4 concentrated. It forms same BaSO4 white PPT plus 2 moles of HNO3. Therefore, option A. Here ionic form and here molecular form. Next. Which of the following will precipitate first when aqueous solution containing sulfate ions are added? So Ba2 plus reacts with sulfate ions to form BaSO4 white PPT. This is confirmation test for sulfate ions. Option D, Ba2 plus. Next. BeF2 is soluble in water whereas chlorides of other alkaline earth metals are insoluble due to. So BeF2 contains Be2 plus and 2F minus. So very high hydration energy. So both are small, very small. Be2 plus small and F minus is also small. So both are having very high hydration energy. Therefore, highly soluble, greater hydration when compared to lattice. Next. So following are the flame test colors which are not correctly matched. Here calcium brick red should be there. Calcium brick red, strontium crimson red, next barium apple green. So therefore 1 and 3. 1 and 3. 1 and 3 incorrect. Next. So which of the following is plaster of Paris? So gypsum CaSO4 2H2O. Gypsum when heated to 120 degrees centigrade, it gives CaSO4 dot half H2O. Calcium sulfate hemihydrate, which is plaster of Paris. It loses water molecules, 3/2 water molecules. Option C, plaster of Paris. Next. So byproduct of Solvay ammonia process or soda ammonia process. So Solvay's process will get NH4Cl as product that reacts with CaOH twice to form 2 moles of NH4OH plus CaCl2. So this is nothing but 2 moles of ammonia plus 2 moles of H2O. So this is byproduct CaCl2. C. So this is the reaction which is happening in ammonia recovery tower. Recovery of NH3. Very, very important. Next. So chloride of which metal are soluble in organic solvents? So BeCl2 soluble in organic solvents due to covalent nature. So most of the beryllium compounds are covalent in nature. Therefore option D. Next. This is the end of the chapter. In next video I will explain one more chapter. All the best and thank you.